In this video, I will show you how to calculate the perimeter and area of a graphed polygon. Let's start with perimeter. The perimeter is just the sum of the lengths of all the sides. So if you were walking this path, it would be the distance you would have to walk if you walked all the way around. So let's start by finding the lengths of all the sides. So I'm going to start with this side over here. And whenever I have a graphed polygon, my favorite way of finding the length is to do the Pythagorean theorem. Hold on, I'm drawing very crooked lines today. So I see this little horizontal piece, and then I see this vertical piece. All right, the horizontal piece is 1, and the vertical piece is, let's see, 7. Let me just double check. Okay. So the length of that, I can find it by doing the Pythagorean theorem. So it's going to be the square root of 1 squared plus 7 squared. Okay. So what is that going to be? Well, that's 1 plus 49. So that's going to be the square root of 50. All right, so that gives me the first length is going to be the square root of 50. I can turn this into a decimal later, but for right now, I'm just going to put the square root of 50. All right, so I'm just going to continue all the way around. I think I'll change colors as I go, so you can match my work to the side. So over here, I have sort of this little rise and run. Hold on, I didn't go all the way. Okay, like this. So the vertical is 1 and the horizontal is 6. So the length would be the square root of 6 squared plus 1 squared. So that's 36 plus 1, so that's going to be the square root of 37. So square root of 37. All right, moving around. Okay, now I'm on this piece right here. So let's see, horizontally, I have this, and then vertically, I have this. The horizontal is 4, and the vertical is 8. Okay, so it's 5, 6. All right, so that means the length is going to be the square root of 4 squared plus 8 squared. Okay. Oh, wait, it's right there. That was 80. So that's going to be the square root of 80. All right, and then finally, I have this length at the bottom, but because that's horizontal, I can just count the squares. So that's going to be 9. Okay, so I'm just going to put 9 at the end of here. So the perimeter is going to be what I get if I add all of these up. Okay, so that's what I'm going to do. I'm just going to do the square root of 50 plus the square root of 37 plus the square root of 80 plus 9. So that's 31, let's see, 2 decimal places. So 31.0, well, actually, that's going to have to round up. So 31.10. So I'm just going to say P stands for perimeter. So 31.10. Okay, let's do the same thing for problem number 2. I'm going to start with this length right here. Okay, vertically I see I have a 3. The horizontal is 4. So that length is going to be the square root of 4 squared plus 3 squared. And that's going to give me 5. Plus I know this is a 3, 4, 5 triangle. I've sort of memorized that, but this is going to turn out to be 5. You know, put it in your calculator if you need to. That's going to be 5. So now switching over to this side over here, I've got my vertical and my horizontal. So that's 7 and 4. So that's going to be the square root of 4 squared plus 7 squared. That is radical 65. And then the vertical piece we can just count. So let's see. Below the x-axis, that's 5, and another 5, so that's just going to be 10. So let's just add all of these up. So obviously 10 plus 5 is 15. So it'll be 15 plus radical 65. .06. Okay, moving on to number 3, just doing the same type of thing. Let's start with this side. So there's my vertical and my horizontal. Vertically, that's 7, and horizontally, that's 1. So that is going to be the square root of 1 squared plus 7 squared. I feel like we had that a minute ago. That was square root of 50. Okay. Now, I can tell that this is a parallelogram because see how this is up 7 over 1, and this is also up 7 over 1. So these are parallel, and these are parallel. See how this is, well, you know, I'll count that out in a second, but I can tell that this is also going to be radical 50. These are going to be the same length because parallelogram. So now I will switch, and like I said, let's count out this one. All right, that is a vertical of 3 and a horizontal of 8. And again, notice that down here, this is also a vertical of 3 and a horizontal of 8. All right, so the slopes are the same. So these are parallel. That's how I knew this was a parallelogram. Anyway, so when I do my calculations, it's going to be the square root of 8 squared plus 3 squared for both of these. All right, so that's going to be the square root of 73. Whoops, I put 37, didn't I? Okay, so the perimeter, we just have to add all these up. So I'm going to do the square root of 73 plus the square root of 50 plus the square root of 73 plus the square root of 50. So that's 31.23. Okay, how about problem number 4? Let's do the same thing. Okay, I can see some symmetry happening here. It looks like these two lengths are going to be the same. Okay, so let's go ahead and get that out of the way, but you can save a little bit of time if you can see that they have the same slope and they're coming from the same point. You know, I can see this is an isosceles triangle, so I don't have to do it twice. I can just do it once. So looking at this piece, for example, okay, so that's going to be 4 and 5, and you know, see what I mean? This would be the exact same thing down here. This would also be 4 and 5, so I'm going to get the same length both times. So anyway, the actual calculation would be the square root of 4 squared plus 5 squared. So that's 41. So this is going to be the square root of 41. So that gives me both of these. Okay, now this one down here is horizontal, so I can just count. And this is 5. Okay, now let's go ahead and do this side over here. All right, this is a horizontal of 1. And I've got this really long vertical. So this is 1, and let's see, that's 5 plus 4. So this is 9. 1 and 9. So that would be the square root of 1 squared plus 9 squared. 9 squared is 81 plus 1, so that's going to be 82. So this will be the square root of 82. Okay, last one. Okay, so we've got the vertical and the horizontal, so this is 1, and this is 6. So I'm going to have the square root of 6 squared plus 1 squared. That's 36 plus 1, so that's 37. All right, now it's time to write the perimeter. Okay, we can just we can add up these 5 lengths. I'll move over here. Whoa. Okay, so I can just do 5 plus the square root of 82 plus the square root of 37 plus the square root of 41 plus the square root of 41 again. And that's it, because I think I started off with 5. So I get 32.94. All right, now it's time to switch gears and talk about the area of some polygons. So the area is the number of spaces on the inside. So if I were to count up the number of squares that are inside this rectangle, that would be the area, all right? Because each one of these squares is one square unit. Now I don't want to have to sit here and go 1, 2, 3, 4, 5, 6, 7, 8 like that. I know that when I have a grid like this, if I want to find the total number of squares, I can just multiply the number of columns times the number of rows. In other words, the length times the width. So I can see that this side is 4, and the long side, the length, is 9. So the total number of squares is going to be just 4 times 9. So that's going to be 36. So the area is going to be 36. And I'm going to put units squared. For example, if these were centimeters, it would be 36 centimeters squared. So I'm just going to put units squared. All right, I always do that when it's area. Now, for this, I'm going to go ahead and mention the formula for the area of a triangle, which is 1/2 base times height. Okay? The base, I can use any vertical or horizontal side for the base. So this can be my base. So the base is going to be, so it's a total of 7. So the base is going to be 7. And then the height is going to be the distance between the base and the vertex that's across from it. So here's the height right here in purple. And that is going to be, let's see, that's going to be 5. So that means the area is going to be 1/2 7 times 5. 1/2 the base times the height. Okay, so 7 times 5 is 35. So this is going to be 1/2 of 35. Okay, so basically that's 35 divided by 2. So the area is 17.5 units squared. All right, so if you have a rectangle, you just do length times width. If you have a triangle, it's 1/2 base times height. For number 7, we need to find the perimeter and the area. All right, so let's start with the perimeter. Now I can see that this is a parallelogram, all right, because the opposite sides are parallel. So I don't need to find the length 4 separate times. I can just find the 2 lengths, and I know that the opposite sides will be congruent. So let's go ahead and find, for example, this side right here. Vertical, horizontal. So horizontally it's 2. Vertically that's 4. So the length of that side is going to be the square root of 2 squared plus 4 squared. Well, that's going to be 4 plus 16, so that's going to be 20. So that's the square root of 20. Okay, so that tells me that this side is going to be the square root of 20, and this side is also going to be the square root of 20. So now let's do the other side. For example, this side, I have the horizontal, and I have the vertical. So horizontally, this is 6 and 3. So that tells me that's going to be the square root of 6 squared plus 3 squared. So that's 45. So I've got the square root of 45. So that means I'll have the square root of 45 here and the square root of 45 here. Uh-oh. I'm doing that dyslexia thing again. All right, square root of 45. So for the perimeter, I just need to add all these up. So I think I'll go ahead and do a small little shortcut here that you can take advantage of. Because I have two of these and I have two of these, instead of going radical 20 plus radical 45 plus radical 20 plus radical 45, I could take advantage of the fact that I have two of these and two of these. So I could write 2 radical 20, because I have two of those. All right, plus 2 radical 45, because I have two of those. So that gives me this. So if I wanted an exact value for a perimeter, there you go. But they're asking me for a decimal, so 22.36. Okay, now the area. Well, the area of a parallelogram is going to be length times width. Well, the area of a rectangle is length times width. So that's going to be just radical 45 times radical 20. All right, so that's 30. So the area is 30 units squared. Okay, how about number 8? This is another parallelogram. So the opposite sides will be congruent. So let's go ahead and find the length of this side. So horizontally this is 1. Vertically this is 6. So I'm going to have the square root of 1 squared plus 6 squared. That's 36 plus 1. So it's 37. So that tells me that both of these are radical 37. Now, the horizontal parts, I could just count. And I can see this is 5. And similarly, I can see that this is 5. Okay, so for the perimeter, I can just add these up. And I think, again, I'll use some of my shortcuts. Well, obviously, 5 plus 5 is 10. And since there's 2 of these, I can put 2 radical 37 because it's just a little quicker to type it in that way. So that's 22.17, got to round up. Now the area. The area for a parallelogram is base times height. Okay, so for a parallelogram, the area is going to be base times height. Okay, now the base is 5. What's the height going to be? Well, the height is the distance between the two bases. Okay, so this is the height right here. All right, vertically. So that height is 6. So 5 times 6 is 30. So that's the area. Will be 30 units squared. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.